Hello, my name is Manager James, and this is Group 19 with Explainable Artificial Intelligence and Deep Transfer Learning for Skin Disease Diagnosis. And the problem being investigated is the complications that arise around skin misdiagnosis in patients with various skin disorders. So, for our background, study shows that around 21% of the patients receive misdiagnosis on their first visits to the doctor, while 66% get seemingly not entirely accurate results, or let me say reports. And also studies show that around 40,000 to 80,000 get misdiagnosis, which leads to death. Then also there is a lot of money that is lost. That's roughly 750 billion, according to studies also carried out, is lost annually by people involving misdiagnosis. So the significance of our research is to bring skin diagnosis, or to bring a model that can not only classify skin disorders but also provide meaningful explanations or interpretations to justify the model's predictions. So for our scope, we shall be looking at strictly 10 skin diseases, or 10 skin disease classes. The problem statement is probably time taken to get these results is actually it ranges depending on the expertise. So in most cases it's actually long. The process to diagnose these diseases is time consuming. So that's one of them.
This is Pius Tumelaze. I'm here to go through research questions. So these are the questions that we'll be doing for us, that we'll be using for our study. Like, the first question is, how can deep transfer learning be used to improve predictive accuracy in diagnosis of skin disorders? And how can explainable artificial intelligence be applied to the field of dermatology to increase adoption of artificial intelligence methods in general? How can deep learning be used to automate diagnosis of skin diseases using imagery data? And last but not least, to what degree can explainable artificial intelligence justify deployment of a skin diagnosis model for public use by dermatologists?
Okay. This is Joshua Mwesigwa, and I'm here to discuss our hypothesis. So in our hypothesis, basically, we're trying to represent some of the concepts that we shall be using we are trying to tentatively answer the questions. We are trying to get an approach, we're trying to get a framework that will answer and help us achieve our research objectives. Basically, we are using explainable artificial intelligence and deep transfer learning to tackle the problem. As my colleagues have described the problem, it's a skin diagnosis problem, and we are trying to make sure that we tackle the problem of misdiagnosis and eliminate all the factors that come along with it. Basically, explainable AI has been something that has grown in the recent years, and it has risen due to the need to explain the machine learning models that have been viewed as black models over the recent years. And then explainable AI as a concept, it tries to estimate, it tries to describe, it tries to give meaning and justify the meanings of the predictions that are being made by any given model. Explainable AI includes a lot of techniques such as Shapley. It includes techniques such as deep lift. It has LRP, which is layer-wise relevance propagation. But we shall be choosing a technique called GradCam. So GradCam, it's something that looks at the activation maps. If I'm to explain and expound more on what GradCam is, it's gradient. It's something that's called a gradient class activation mapping. Basically, this illustration here tries to illustrate how GradCam happens. The model tries to look at all the activation maps that contribute to the final output that is being output by the model. And then what it does is it tries to find out which pixels are important or which pixels were important to the model or to its predictions for a given class. Basically, we shall be using GradCam, and it's being explained here. Maybe to talk something more about deep transfer learning. Deep transfer learning is a technique that whereby we literally use a pre-trained model that has been trained on a different class of problems, and then we use it on a different problem, maybe another problem. Basically, we shall be using a model called VGG16, which has been used in recent research, medical research. We shall be using it, and we shall be training a feature extractor on top of VGG16 to learn features that are important in skin diagnosis. Let me welcome a friend of mine to continue.
So, tomorrow is a bias here for research objectives. So, these are our objectives for the study: to develop, test, and evaluate a deep transfer learning model that can diagnose various skin disorders from a sample space of over 23 classes; to deploy interpretability and explainability using explainable AI techniques like layer-wise reference propagation and graduate-weighted class activation mapping for understandability of the learned skin disease imagery features; to justify model prediction using explainability methods and deploy the model in a mobile application that can be used by health personnel; to scrap the web and not only stop at detecting but provide the victim with viable content that can help them go about how to treat the disease. Thank you.
About the data set, we have actively spoken to DAMED. DAMED is it's an online portal that's internationally recognized for medical data that's related to skin diseases. So we have actively sent an email, and we're actively waiting for a response for them. We have sent a research email requesting for the data, and we are waiting for a response from them.
Hello, my name is Paul Enoch Asanda, and I'm taking through the methodology. So we're going to look at the method and how the method is going to be carried out for this concept. So basically, taking in the concept of deep learning, the subset of machine learning, and then convolutional neural network, the heart of deep learning, and then also adding in the explainable AI and deep transfer learning. So the first step that's going to take place is we collect the data set, like Joshua said, from the DAMET website, where we get the largest dermatology source of data. Now this data, after collecting the data, it will have to go through a process called pre-processing of the data, and then the techniques which are involved in the pre-processing are resizing, pixel normalization, and image augmentation. So resizing, this is where we're going to look at, we're going to fit the image. We're going to resize the image such that they fit the VGG16 model, because the VGG16 model takes in a size of 224 by 224 images. So for the image augmentation, here we are going to try to generate more data in a way that by resizing the data, we increase the data by generating new data points, and generating new data points involves flipping the image, translation of the image, rotation of the image, and this will help improve the performance and the results of deep learning model. Also, we look at the pixel normalization. This is where we rescale the image into a range of 0 to 255 by producing pixel values from 0 to 1. This helps in generating normalized pixels, which are used in gradient calculations. And once we get the gradient calculation, it leads to a consistent data. So now the process of proposed architecture of deep transfer learning. So like I had said, we get the data set. It goes through pre-processing techniques, and then we pass it through the VGG16. So here at the VGG16, according to the image, we add on a feature extract layer on the hidden layers of the VGG16 model, such that we can be able to evaluate the model, the performance of the model. And once we get the performance of the model, we get to know how and why the model predicted what it predicted through the explainable AI. The explainable AI. But here we attack the GradCam, because the GradCam is the one that helps us to describe why the algorithm we chose predicted what it predicted. But this is going to be done through evaluation metrics, and one of the evaluation metrics are confusion metrics, precision, accuracy, recall, area under the curve. That's all that, and those are the references.
Thank you.
Thank you.